Nothing. I don't see you on it. I'm on it.
Why am I not?
I don't see you.
Well, I'm waiting, see,
Oh, I put, look, I got it. I put the ID in. And I
I
didn't
just
have to,
clicked the link, I just clicked the link
and I didn't have to register. Oh, it says 12 people are in the waiting room,
so I'm one of them.
but that's good. We have at least 12 people.
See,
That's your student. Here, are these your students?
looks like, yeah,
Yeah.
that's okay. See, here is the link. And here is the
Yeah,
link.
yeah.
Now I click the link.
But I'm okay. I'm in the waiting room. Wait, home base. Jerry Miller's on. Hung May's on.
Okay, okay.
Hung May's on. Nellie is on. Yes, you are. Here you are. You're in the waiting room.
In the waiting room, but not in the meeting.
I know. Who's going to let us in?
Okay, it says now host has joined. You will let them know in between.
Oh, I'm the host. Hey, look, what do I do? It says,
Yeah. Oh my goodness.
what do I do? Here, you want to do it?
Jesus Christ. Click admit to everybody. Hold on. I'll admit myself, everybody. So whoever. All right. Yeah, here. Take it. Yeah. So everybody here is admitted.
Okay, that's great. Where is she? Let me see.
Here we go. Yeah.
Okay. Yeah. Okay, let me do this. Um, um, hello, everybody. Can you hear me okay? Hello? Can you can someone unmute themselves and answer me? Can you hear okay? Okay. Thank you for joining us. I appreciate um, uh, even though this is finals week, that we're having this opportunity uh, to um, uh, to go ahead and have the last presentation for this semester. This is a young lady from our master's program who will be presenting today. Oh, let me see. We have. Oh, okay. Thanks for the note, Hong Mei. Yeah, we need to let Nelly. Hold on just a minute, Hong Mei. Yeah, I'll try.
No. Now, can you guys hear me? Dr. Hongmei, can you hear me?
Yes.
All right. All right. I will be admitting the people from if somebody else comes, but so far we have 27 people in 28 now. Okay. So who is the presenter? Where is the presenter?
Celestina, can you share, please?
Yes,
Yeah, you start share your screen.
Okay. Can you share screen, Celestina?
yes, I can do that.
Yeah, and Dr. Hongmei, maybe you can present the presenter, tell us something about her. She's your student, right?
Oh, okay. Thank you. So today I'm happy to introduce Celestina Kolog. She is a master student at the
Yes, I
CIS
did.
department. She worked on quantum machine learning. The use quantum machine learning in detection phishing phishing email. So the method we use focus on phishing URL. So use XAI. She will graduate this summer, and she will start her career as a PhD at a computer engineer school, College of Engineer. Okay, thank you, Ms. Kellogg. That's your presentation. I
Thank you.
leave this to you, okay?
Okay. Okay. Yeah.
Okay, I don't know if, oh,
Okay, Miss Kola. Okay, excuse the we're still trying to get a little organized here because people are still in the waiting room and I'm trying to get them all in here. But while we're waiting, Dr. Mativa will let people in from the waiting room. But I really appreciate Ms. Kolog, your agreeing to give this presentation today. We really appreciate Dr. Hongmei Chi in her work that she's been doing with you. This is an exciting area, a very difficult area, the whole world of quantum computing. And so we're excited to hear what you are doing. And so we can go ahead and get started. I think most people are already in the online with us. So are you ready to start then, Ms. Kolak?
yes.
Go ahead, please.
Um, okay, thank you so much. I don't know if it's okay to put on my camera or leave it that way, but
Yeah, we see it. We see the screen well. Okay.
okay. All right. Thank you so much for the opportunity once again. And my name is Celestina Kolog, a graduate student, and I'm so excited to be here to tell you a little bit of what I've been exploring more on quantum computing. And as the topic goes with exploring quantum neural network, which is known as a quantum algorithm, and phishing URLs using explainable AI, which is artificial intelligence. And we all know that there's a lot of phishing going on every second, and it's either attacking an individual or an organization, the whole wide world. And what if the key to stopping this isn't about just the AI getting smarter every day, but understanding how the AI thinks and makes decisions? So today I'm going to explore a little bit more based on one algorithms of quantum machine learning, which is QNN, known as the contour neural networks. And these are the basic outline. I will basically go on with introducing to you a little bit about what contour is and what the problem statement of this is about, and what are some of the research questions that comes out with this topic, and what a little bit of explainable artificial intelligence is about, and give a bit of scenario and the data set used in the tools and methods and model training, using the line analysis and the sharp analysis, and some of the limitations that comes with these tools, and also my conclusions. So as said, quantum is a very field that has very exploring ways and also difficult at the same time because of what is known for its qubit. So quantum machine learning is a field that combines quantum computing with artificial intelligence that improves in its speed, accuracy, and efficiency. So as we all
Oh,
know what a classical
Go ahead.
quantum computing is, quantum uses qubit to present its data, whilst the classical uses bits
Yeah.
and bytes. And because of its qubit, it gives us the opportunity
Wonderful.
to analyze more data with its efficiency and the speed, and also improves in its accuracy. So one will ask, what is a qubit? A quantum qubit is also basically known as a bit or a byte when it comes to the classical quantum machine learning. And it's basically talking about you existing in multiple states simultaneously at the same time. So we are all students, most of us are students here. You go to the library to study, you are having a headphone on at the same time you are reading. You're doing two things at the same time. Qubit is basically in a real life an explanation of that, doing things at the same time, or being at the same place at the same time. So with this property, it makes quantum machine learning more accurate and more advanced as compared to the classical one. So what is a quantum neural network? It is a quantum algorithms. We have a lot of algorithms when it comes to quantum neural networks, but this particular algorithms combines the neural network to process data more differently as compared to traditional model as the classical quantum neural networks. And in cybersecurity, when you use quantum neural networks, it's good when it comes to detecting phishing URL websites using the URL structure or the secret, the SS presence, which is also known as the secure socket layer as well. So when it comes to phishing, as said already, there's a lot of phishing that happens every second in the world. So it's a type of cyber attack that uses email, SMS, or phone, or social media, or social engineering techniques to kind of entice a victim to share sensitive information that are basically known for you alone, which can also be known as your password or your account numbers for the victim to use as a malicious file that they can install weapons of violence inside it and extract information from it. So analyzing these phishing emails, we have to check on the headers, which comes with which IP address that you are going to trace it, and examine what kind of links that are attached to it, or what kind of malicious attachment that are in it. Email have a header and also a meta and IP address, which you can trace about to as well. So tracking this phishing through a network loss, you can also monitor DNS requests and also suspicious connection to as well. So what is the problem statement? When we come to the problem statement, there are various ways that raises problems here, but the main problem is there are a lot of applications when it comes to artificial intelligence, but not all engineers or software engineers that create them can figure out the explanation behind the decision of artificial intelligence. We use a lot of artificial intelligence algorithms to process data, train models, but we don't know what is the decision behind those models. You use an algorithm that gives you a very high accuracy, but what is the decision behind that algorithm to make that accuracy really high? So quantum artificial intelligence models are typically a black box systems, meaning their internal logic isn't easily understandable when you look at it. And also, for instance, too, when it comes to you trusting the AI decision, what are the correct and the base importance of the digital clues that you gathered to trust that this is actually an evidence that a decision AI has made that you can trust that it's really true that this accuracy is good. So how can QNN detect phishing URLs, and how can explainable artificial intelligence decision in phishing detection be made explainable? So when you look at the hypothesis, combining this algorithm, which is the QNN, with the explainable tools like Lime and Sharp, it enhances the transparencies and also trusts when it comes to digital forensics, decision making, or algorithms. So I've talked about what as explainable AI is, which is a field that comprises or focus more on understanding what the AI prediction is all about. It allows the user to verify your information or your outputs and also validate it, and also context that the AI outputs are also in a humanly way understandable, so that you can understand what decision of the AI is basically all about. So it focuses more on model explanations. As said, the model could be an algorithm, so you ask an AI to tell you that is this black or A, and the AI you have let's say you have a box full of 50 reds and 20 blues. And in that algorithms, you're asking an algorithm to predict that there are more blues more than red. And the AI comes back telling you that, oh yeah, it's true. We have 50 blues and 20 red. So it's really true that you have blues more than reds. But the point is, what happened? What are the decisions that the algorithm took to make that decision that it's really true that you are right? 50 blues and 20 reds are inside this box. So this is what artificial intelligence, explainable artificial intelligence is all focused on, making you understand and also explaining what the algorithms is all about. So Lime and Shapes are the two leading tools when it comes to this space. And I basically happen to explore a little bit more about it. But there are a little bit some of the frames that are used in this detection, which can be an image auto generation tool as well. So which is also a non-coded machine learning model that is come up by Google, and it's also a model analyzing tool as well. And Line as explained prediction with local models, and also Sharp, which comes with the feature importance using the Sharply values too as well. So in this scenario, we are going to look at a phishing campaign that is suspected, investigating using a trained model called the QNN to classify suspicious URLs and non-suspicious URLs. As explained, you have a bunch of data set, which I'm going to talk about a little bit anymore. So the Lime is to interpret why an individual prediction was made, and the Sharp is to understand the overall future contribution across the data set. So this is the data set, which is also designed to train and evaluate machine learning models to distinguish the phishing URL website from the real or the legitimate URL website too as well. So we have a total instance of 10,000 with a total features of 49 features, including your ID, logo, column, and also a column label, the class label. So 1 representing that the URL is phishing, and 0 representing that the URL is legitimate. So these are the tools that are used in it. We have the Penny, which is a library in, it's a Python framework that is used for contour machine learning. And we have the Python, which is also a library based on PyTorch, a Torch library as well, which is used in machine learning. And Google Colab for implementation, whereby it's also an online text editor, also known as Codio, or you can use Visual Studio. That's similar to that. And the method uses processing the data set and applying principal component analysis to reduce to 4 principal components. Is basically putting you in groups that are basically matching the highest dimension features space to the lower dimension feature space too as well. And training the model, which is the QNN model, predicting and explaining with your local and then your global. So with the model training, we came up with a model accuracy of 0.77, which is actually a good stand, not really, let's say an average, because the The most thing is when you get a model of 0.80% or above, but it's basically logically the same thing as 8. But the main focus is to understand the behind decision that was made to get you this model. So the model accuracy was used to test the data, and the results are shown as the classifications and also the capabilities as well. So with the line analysis, with the principal component analysis features that were reduced into 4 features, we have the principal components 1, 2, 3, 4 down here. I don't know if you guys can see. Yeah. So this basically is having the blue one supports that this URL is 84% legitimate, and the orange one supports phishing. So basically there's like a vote that makes up the blue number and a vote that makes up the phishing. So in this model, it basically focuses more on telling you that this percentage of the URLs are more legitimate, and the rest is not legitimate. So in this voting, you can see that there's more into the blue, which whereby the principal component of 2 is less than or equal to 1.34, and also as the PC1 and PC4 and 32 as well. So this might be technical, so I put it in writing so that I can break it down for a little bit understanding. So the line interpretation shows that like why the AI model decided that a specific URL is legitimate and not a phishing attempt. So the prediction probably tells us that the model is 84% confident that this particular URL is safe, and only 16% was being suspicious that it is not, it is a phishing URL or site too as well. So when you come to the line as explained about the principal component analysis, it breaks down the reasoning by showing the 4 components, which I already explained earlier, and which all push the model towards choosing whether it is legitimate or it is not legitimate. And these features are grouped, resulting from the original URL characteristics, like the length of the URL, the symbols of the URL, so as well. And also the blue bars represent how strongly each feature support the decision. It's like basically those features or those groups, that is the P1, PC1, PC2, PC3, PC4, makes a decision by having a vote. And they vote based on the length of or the characteristics of the URL and the symbol to tell whether this particular URL is phishing or it is not phishing. So all of them support the decision that with the largest bars, meaning that there is more influence in each group, that tells you about that. And when the explanation basically let us understand the why behind that particular decision, proving that the model made a reasonable and trustworthy choosing the real and meaningful information. So now, as explained, this is basically the logic of it. The model predicted 84% legitimate and 16% phishing, and the features that was grouped that supported that legitimate classification was the principal component 2, 3, 4, and then so as at 1. And it confirms that it confirms the trustworthiness of the decision of the machine, the model of the QNN. So the sharp analysis, whereby it tells us about what it does or it influence of each of or all the features for each prediction. So the model has a higher future values and a lower future values. And the red dots and the blue dots are basically a classification of votes. That's the basic real time I can put this into. So the right ones support legitimate and the left ones support non-legitimate, which is phishing. So the higher ones are the red dot and the blue ones are the low futures red dot. So when you come to making this more understandable, so the sharp basically is like a bunch of tiny votes that the AI kind of shows. So which includes, like, it gives clues of how the future helps in deciding whether each URL is safe or it is not safe. And each dot on the graph is a URL. So whether it's a blue or it's a red, it shows that all of them are the tiny dots, whether blue or red is a URL. And based on that, the higher demand or the higher value of it is the red and the blue, which tells you which one is efficient and which one is safe to go by there. And the position too tells you how, like, each specific clue, like a long, whether it's a long URL or it's a short title, push the artificial intelligence in one direction or the other. So as well. So it make the decision by opening, like, it's like you tell it, let me see what is in your mind, making a vote and coming out to tell someone that I've made a vote. But how will I know that you've made a vote if you say that you vote for A, but you went to vote for B? I will not know. So it's like you trying to see what is actually your mind. I know you vote for A, but I'm asking you and you're telling me that you vote for B. So basically, I know this makes sense, but yeah. So these are some of the interpretation when it comes to the sharps. It enables the phishing detection to see how different the metadata feature contributes across all the samples, and it also confirms the model isn't biased or is misleading, or also justify that the AI decision for legal and misleading. When it comes to the limitations, the model are still emerging, QNN is still emerging and resourceful intensive, which I used it in one of a project that it performed more well as compared to the classical contour machine learning, which is good. So it's still an explorable place that people are interested in. And Lime also gives only the local interpretation of it. And the data quality directly affects the model reliability, whereby I talk about the principal component analysis that you have to group it to match with the dimension future space to the lower dimension and the higher dimension too as well. So the chart can also be complex and time consuming because it takes time to load, and also the tiny dot to really explain what is actually going on. So in conclusion, we can basically say there's an improve in artificial transparency when it comes to phishing URLs, and Lime and Shape reveal reasonable behind prediction as well. Engineers or software engineers can trust that AIs with more confidence when they basically know what it is happening. And also, this lab kind of explore how responsible when you deploy artificial intelligence in cybersecurity like phishing too as well. Yeah. As said, if there's always a way that we can understand, it's not about what the key of this is, not about how AI or artificial intelligence gets smarter, but it's about how we understand how artificial intelligence actually works when they make decisions, and also some of the algorithms we use in data prediction and data analysis, not knowing that we don't have to get smarter to predict with the higher accuracy, but understanding what is actually decision behind all the algorithms. And yeah, thank you.
Oh, gosh.
Yes.
Thank you so much, Ms. Kolog. This is excellent. Beautiful, beautiful job. And really want to thank your mentor also, Dr. Hongmei Chi, for working with you on this. So let's open it to the audience here. Any questions from the audience about what from the participants here? Please unmute yourself if you have a question, or you can put it in the chat if you prefer, and I can raise the question with Ms. Kolog. So let's open it for questions from the participants. Any questions? Comments? Anyone? Oh, here we have one. Great job. Amazing. Thank you. That's great. it is a very good job. I have a couple questions, if I may, Ms. Kolog. So you've done a very, very thorough job on this. I'm very impressed. I'm sure the participants are very impressed. This is quantum computing is a difficult area. It's not very, very different. How long have you been working on this project?
I started last year.
Uh-huh. Did
Yeah, but
when you started this, did you have any background in quantum?
I did not. I did not, but I had a background in machine learning, so which is
Uh-huh.
basically a little bit easier, and
Right.
it was, yeah, because if you have a little bit of what machine learning is it's very easy, but not easy when it comes to the qubit side, because it was really kind of interflicting with what you know, and you're not getting it at the same time. But it was a it was worth exploring because I get to learn a lot about certain things I didn't know.
So there is one question in the chat from Miss Carrie, I guess.
Mhm.
What made you want to pick up this project?
Oh, that's an interesting question. And I talk about this all the time. But yeah. Um I actually when I got this opportunity, I heard about it, but I really wasn't really interested in it. So when Dr. Shi told me that if I'm interested, she can mentor me to work on this, I basically picked it, and then I realized that I'm I'm international student. The point I'm trying to make here is that it's not about you knowing stuff, it's how long are you being exposed to stuff that you know. So it wasn't really something at first that I see myself doing, but the fact that you get to explore and get to advance certain things you don't know is something I was really interested in doing. But then when I get inside, it got interesting, so I stayed. Yeah.
So okay, so now you've picked up a tremendous number of skills, a tremendous number of skills.
Yeah.
Where would you like to go with this, with these new
Wow.
skills that you have?
So I would like to explore it more because I still feel like there's more in consume that I've not really gotten deep into it. So with these skills, I would like to see myself not only stuck in it, but also using it to bring something to life. So exploring more with this, comparing it to or combining it with large language model to come up with something. So that is the future that I'm looking at. It could be an app that has a lot of labs related to quantum, or it could be something that is teachable or explorable to people that don't have any background when it comes to computer literacy. So I'm basically looking forward to working it, combining it with large language model with the skill.
Oh, sure. No, that's excellent. Excellent. And when do you graduate?
Graduating summer, this summer,
Okay.
2025. Yeah.
So there's another question here I want in the chat. I sort of want to rephrase it. It said the Miss Carey brought up working outside of your comfort zone. So how did you feel about that? Did you feel outside of your comfort zone and some basic challenges that you had to overcome here?
Well, honestly, it didn't really feel that because when my first year in grad school, I basically took a lot of cybersecurity classes.
Uh-huh.
So I'm a computer science major. So it's like I'm shifting from computer science to cybersecurity. But it didn't feel that way because I took cybersecurity classes. So it kind of really flowed well when it came to that. I didn't have to like maybe look for something new, but some of the classes I took was a little bit like a background I had. So when I came to like talking about cybersecurity related to phishing and all that, it all aligned well because I already had classes. So it wasn't really feeling like I'm shifting. But working out of comfort zone, I would say yes, because I didn't know a lot of things. So I basically have to do some research. So yeah, it's fun when you get to read and find out people are really doing something and we're like, oh, I didn't know. I heard of this, but I didn't know. You see words that you be like, okay, so this is what they meant when they mean that this is the word. So it's like you just exploring more and getting back. Yeah, it wasn't really feeling like out of comfort zone, but a little bit out of comfort zone because I had to do a lot of digging into it. So yeah.
Yeah, that's very, very good advice for our people, our young students that will follow after you. Excellent advice. Any other questions from the participants in the seminar? So if not, I again want to thank you, Ms. Kolog. This is excellent presentation. You did a great job. And again, I want to give a shout out to your advisor, Dr. Chi, for working so closely with you. We really appreciate that. So thank you very much.
Thank you
And
so much.
yep. Okay. Congratulations. Take
Thank
care,
you.
everybody. Take care.
Thank you so much.